Here's a guy who thinks that religion can explain reality better than science.
Assalamu alaikum wa rahmatullahi wa barakatuh, everyone. Welcome to my channel. I'm Abdullah Al-Andalusi, and today I'm going to be talking about the reason that science cannot ultimately explain reality. The reason I want to talk about this is because in my next video, I'll be discussing proving God's existence by rational argument. But if some people mistakenly think that rational thinking cannot prove God's existence because it doesn't use scientific experiments, then no argument would ever convince those people otherwise. Now, it's pretty common for skeptics of the atheist variety to shun or sometimes outright disparage explanations of reality that use rational inference.
Strictly speaking, that's not true. If you are inferring that something exists, rationally inferring it from empirical evidence is perfectly fine. The problem is when you try to rationally infer existence a priori, that is, without basing your inferences on empirical evidence. To show that something exists is to show that it is not fictional. It is to show that it is not a mere concept. The reason you can't prove anything's existence a priori is because you can't prove that something is more than just a concept using nothing but concepts. You have to involve something other than pure concepts.
Instead, they declare the faith that science alone is sufficient to discover truth about the world.
I think that's a straw man. Science doesn't even really aim at truth, whatever you even take that to mean. It aims at models of reality that consistently, falsifiably, and most parsimoniously predict observation. This is what scientists mean when they say that a model or theory explains reality. It doesn't mean that it necessarily accurately describes reality, but rather gives us a means of predicting our experiences of it. Scientific models just have to work. They don't have to be true in the sense of accurately depicting reality.
So before they even hear arguments for God's existence, they've already rejected the possibility that these arguments can produce any truth at all. So this video is about smashing this assumption. This assumption not only disregards what rational thinking really is and can do, but also ignores the basis and limits of science, or physics if we're going to keep it simple, since all science is underpinned by physics. Physics is the study of what is tangible to our external senses. Now, let's consider this question. If there was a physicist and a simple rational thinker, both on a boat studying a lake, the physicist's interest might only be to drop an anchor attached to a rope to help determine how far to the bottom the lake was. But what if the lake had a bed that was so deep far down that there wasn't enough rope in the world to measure it? Would it be correct for the physicist to conclude that it is impossible for him to ever know if the lake even has a bottom? No, of course not.
Nor would a physicist draw that conclusion. You could infer that a lake has a bottom from the empirical evidence of how gravity, density, and liquids work. A lake of infinite depth would be of infinite mass, and we know from observation of mass and gravity, not from pure reasoning, that a body of a certain mass will become a star. It is from this observation that we infer that a lake must have a bottom.
His companion, the simple rational thinker, on the other hand, could help him by inferring that there must be a bottom of the lake, because for the water to be held up, and to be held up at the level it is at, there must be something somewhere below holding it all up, without need to do any experiments to verify this.
But that wouldn't be a purely rational inference. It wouldn't be an a priori inference. That could only be inferred from the empirical evidence that water needs to be held up. There is no purely logical a priori problem with the idea of a lake that just floats on nothing, or which is of infinite depth. If you rely on pure reasoning alone, you can't actually eliminate the possibility that the lake has no bottom. Such a thing could easily be coherently imagined. You can only infer that such a thing is impossible if you have empirical experience of how gravity and liquids work. Sure, such an inference would only be inductive, but without inductively inferring it from observation, you would have no basis at all to say that the lake has to rest on something. On a purely conceptual basis, there's no problem with that idea at all.
Sure, he wouldn't know the measurements or how deep the lake was, but the ultimate conclusion that the lake has a bottom would be the best explanation for what they both can observe. Like a lake that is too deep to be measured, the examination into the ultimate explanation behind reality is something physics will simply never be able to answer using its methods. To demonstrate this, let's consider a current mystery: the origin of quantum vacuum fluctuations. Now, for anyone unfamiliar with this phenomenon, in our universe there is no such thing as truly empty space, at least as far as we can tell. But what we call empty space consists of continuous fluctuations of energy. What causes these fluctuations of energy? Currently, we don't know. Do they come from another dimension underneath ours? Does each fluctuation come out of nothing and go back into nothing? And if so, do they come out of nothing by themselves, or are they caused by something else?
Well, they don't come out of nothing, they come out of space-time. They couldn't occur at all if there were no space-time in which to occur.
If our technology will never be able to see the cause of these fluctuations, we would never be able to prove that they come from nothing. And likewise, if something is actually causing these fluctuations, we would never be able to prove it or know what that something is. So while the study of physics uses observation of objects under controlled conditions, i.e. experimentation, it will never be able to tell us what is beyond the boundaries of our physical reality, quite simply because it could never cross them.
Well, what does beyond the boundaries of physical reality even mean? It doesn't seem to me that even at a purely rational level, an explanation can get beyond physical reality, because it's not clear to me what the concept of beyond physical reality even means.
And even if it reached a boundary, it wouldn't know for sure that it even was a boundary.
What does it even mean to say that there is a boundary to physical reality?
Another example I could use is the question as to whether there is anything smaller than Planck space and Planck time. To explain, physicists generally consider that our reality consists of pixels, that is the smallest possible unit of space, and the smallest instant of time between any 2 points of the universe. There isn't the infinite amount of points that mathematics allows us to imagine. But actually, reality seems to have fixed, indivisible lengths between any 2 points. But how do physicists know this?
They infer it from empirical evidence. If you observe the physical constants of the universe, like the gravitational constant, Planck's constant, etc., it becomes clear that it is incoherent to speak of units of space or time smaller than the Planck length or Planck time. The Planck length is the smallest unit of space, and the Planck time is the amount of time it takes for something traveling at the speed of light to cross a Planck length. In order for anything to meaningfully be said to happen at all, it needs to happen over the space of at least a Planck length, and it needs to take at least a Planck time to happen.
Well, many claim to know, all because of Max Planck. The Nobel Prize-winning German theoretical physicist Max Planck accidentally discovered that the equations he was using in his work on radiation from perfect absorbers of light was wrong because they wildly failed to accurately predict the results of his experiments. And by wild, I mean the equations he originally used predicted infinite amounts of ultraviolet radiation coming from his experiment, which was hilariously titled the Ultraviolet Catastrophe. Thankfully, the experiments produced only finite amounts of radiation. For anyone less familiar with the history of physics, whenever an equation that claims to model how something works inside our universe predicts an infinity, physicists know that a telltale sign the equation is wrong.
That's not always true. Scientists still believe that black holes have infinite density.
Planck was only able to predict correct results when he tweaked the equation he was using to stop treating energy as being something that was infinitely divisible, but instead treat energy as coming in discrete packets or quanta. Yes, you guessed it, this led to the discovery of quantum mechanics.
And this is actually a pretty interesting story, because Planck made such a profound discovery when he was commissioned by the German government to carry out the comparatively mundane task of finding out how to make the most energy-efficient light bulbs.
And the standard model of physics, which predicts to an extreme degree of accuracy a large number of phenomena in the universe, except gravity, but that's another story. Using the discovered Planck constant, an arbitrary number that is used to make the equations work.
It's not an arbitrary number. It's calculated from empirical measurements. You make it sound as though Max Planck just pulled the number out of his ass. That's not how it happened.
Physicists discovered that if they manipulated the equations used in quantum mechanics, they produced what appeared to be the smallest units of space and time too, Planck space and Planck time.
To say that they manipulated the equations makes it sound sinister. In reality, they just derived values from the equations to find the Planck length and the Planck time.
Many physicists would tell you that at lengths and times smaller than those units, reality doesn't make sense or has no meaning. What they actually mean is that the equations they use to make very good, accurate predictions about a large part of reality simply don't go smaller than those lengths and times.
Well, for example, in order for observation to go smaller than the Planck time, the speed of light would have to be faster. In other words, the impossible would have to be possible. We can imagine it, but what we imagine could have no consequence for observation. In other words, it would be useless. Imagining such a thing would have no point whatsoever. The reason why we can make very accurate predictions based on these equations is that nothing that happens, if anything does happen, at scales smaller than the Planck scale can have any observable consequences.
The point is, if those units are actually as indivisible as many physicists believe them to be, they would never be able to prove it for sure.
Yeah, but that's true regardless of whether your inferences are a priori or inferred from observation. We can imagine a unit of time smaller than the Planck time, but there's no a priori way of demonstrating that such a unit of time can occur in reality. And all a posteriori evidence seems to indicate that no unit of space or time smaller than the Planck scale has any observable consequences.
Equally, they would never know for sure if they couldn't go smaller than those units. And even if they ever could, they wouldn't know for sure if they could go smaller still. So what does this all mean? This means when dealing with what is beyond the boundaries of reality, it can never be solved by a physicist with an anchor tied to a longer rope.
Nor can it be solved by anyone else.
Physics can only ever tell us how things work inside our bubble of physical reality. But what is ultimately behind physical reality and outside it, it could never venture into. But don't fret. Where our instruments can't go or can't confirm, our rational thinking can.
I'm not convinced that this is true. To say that something exists is to say that it is more than merely a concept. And to say that something is more than merely a concept means that the thing which its concept represents has location in space-time. It's only if something has location in space-time then it can be observed, or have effects which can be observed. What would it even mean to say that something exists in any other sense? And how can you infer that something exists if not from observation?
And by rational thinking, it just means thinking that avoids contradiction, is based on evidence, and avoids unwarranted assumptions.
If it has to be based on evidence, then it is bound within physical reality because only physical reality can produce evidence.
Although anyone who knows Latin will tell you that the root ratio means thinking anyway. And so rational thinking is actually just a tautology. And even if we lived 2,500 years ago, we can still seek answers to the ultimate questions that physics simply can't answer. We need only resort to rational thought. The truth is, it is rational thinking, not experiments, that tells us that from nothing comes.
Which is why the doctrine of creation ex nihilo makes no sense. If it makes no sense to get something from nothing, then even a god can't coherently get something from nothing. That's why I think that the most rational inference is that there never was nothing. At all points in time, at the very least, time itself existed. Therefore, at no time was there absolutely nothing. This is true even if time is past finite. Even if time only goes back 13.7 billion years, at no point in those 13.7 billion years was there nothing. And the only coherent sense in which you can say there was nothing before time is if what you mean by that is there was no such thing as before time. There was never a state of affairs you could call nothingness followed by a state of affairs in which the universe exists. Nothingness is not a state of affairs. There has never been nothingness. The universe didn't come from nothing because it didn't come at all. There has never been a time when it wasn't already here.
Because nothing is not a thing, and so quite obviously, it can't do any actions.
Nor can any actions be done to it, which is why even a god cannot get anything from it.
Rational thinking also tells us that contradictions are impossible. Whereas all physics can tell us is it's never encountered any yet. So if we ever encounter something in physics that appears to look like it comes from nothing or comes from a place we don't know,
well, neither the universe nor quantum fluctuations appear to come from nothing. The universe looks as though it didn't come at all, let alone from nothing, and quantum fluctuations appear to come from space-time rather than nothing.
We can infer that it must be produced by the action of something else that already exists, which brought about that something, whether it's quantum vacuum fluctuations or the entire universe itself.
Well, to say that something already exists is to say that it occupies space-time. To say that anything already exists presupposes that space and time also already exist. Space and time cannot themselves coherently be created by something which already exists, because that denotes that space and time also already exist prior to their creation. Space and time cannot, therefore, be coherently described as having been created. Since the universe is the space-time continuum, the universe cannot be coherently described as having been created.
To everyone who helps me out on Patreon, you're a big help. Thanks so much.